In this section of this course, or in this new chapter, we are going to be talking about object-oriented programming. Now, if you notice, I had already created a new folder called Chapter 10. So this is where we are going to be writing all the code which is required for this chapter. So you can see I created two files. The first one is car.py and the second one is classes.py. I want you to ignore this car file for now as we're going to use it in the future, but I want you to create a Chapter 10 folder and then create a new file called classes.py and then save it. So let's get right into what object-oriented programming is. So object-oriented programming, or OOP for short, is a different kind of programming paradigm, or it's a different kind of programming style that helps us to structure code using classes and objects. Now, I am going to explain exactly what classes and objects are, but I just want you to, get the overall idea first. So object-oriented programming, I said it's a paradigm that helps us to structure code using classes and objects, and it actually helps us organize our code properly. Now, before I even start writing any code and explaining in detail what classes are, we need to talk about a different paradigm which I had taught you in this course. So if I go to chapter 8, you can see that we had spoken about functions. So functions are actually a different way of writing code, and it's actually a different paradigm of writing code. And this is called the procedural paradigm of writing code. Now, procedural programming basically means that we structure code into different functions or different procedures that perform some specific kind of task. Now, if you look at this project which we worked on in chapter 8 called mini project, we can see that we have several functions created. The first one is called add contact, second one is called view contacts, then we have delete contacts, and we have the main function. So you can see that all the code basically have been divided into different functions, or we can call them procedures also. So different functions or procedures that perform some specific task. So this is the procedural way, or the procedural paradigm, or procedural style of writing code, where code is divided into different procedures or functions that actually perform some specific task. Now in Python, we can actually make use of different paradigms depending on what your project needs and the scope of what you're working on. The first one, which we talked about, is the procedural, which is the function. Now, I'm going to be teaching you the second procedural method, which we'll talk about in this course, and this is object-oriented programming. Now, like I had said earlier, object-oriented programming is a paradigm that helps us structure code using objects and classes. Now, you might ask yourself, what exactly is a class, or what exactly is an object? Now, a class is a blueprint that helps us to model real world entities or abstract concepts. Now, let me give an example. Let's say, for example, you want to model a car within your program. How exactly do you do that? We can make use of a class to actually model a car within our Python program. Now, in the definition I gave, I explained that that classes are used to model real world entities or abstract concepts. So by real world entities, what I mean is you can actually model physical objects. Let's say, for example, we want to model a car again. We know that a car has a model. We know that it has the year of production. We know it has, for example, the type of engine it has, the number of doors. So those are physical attributes that this car has, which we can actually model within our program. Then by abstract concepts, I mean something like bank account, something that you can't hold. So a bank account can be an example of an abstract concept. We know that a bank account has, the balance that is currently present in the account. It has, the user or the customer who actually owns the bank account. We know that it has transaction history, things like that. So we can actually model these abstract concepts, things that you can't physically hold. We can actually model these abstract concepts within our program and within our code. And I'm going to be explaining in more detail as we proceed. So a class, like I said, is just a blueprint for modeling real world entities or abstract concepts. And if you want to create a class in Python, all you have to do is just type keyword class followed by the name of the class. Now, in Python, the naming convention for creating a class is usually using an uppercase first letter. So let's say we want to create a class that models a car. We're going to call it car. Now, note that the first character should always be an uppercase. And if it has multiple words, so let's say we're trying to model a car company, this class will be called car company. Notice that each word starts with an uppercase letter. And this is the Pascal case, which we had spoken about in chapter 2. So if I go to chapter 2 under naming conventions, you can see that under Pascal case, the first letter of every single word is a capital letter. So that is exactly what making use of. Anytime you want to create a class in Python, you should always make use of the Pascal case. But since our class is called car, I am just going to call it car. So we say class car, we put a colon, and in here, let's just say pass for now. Now let's analyze this syntax. So anytime you want to create a new class in Python that models something, we first use the class keyword, space, the name of the class the name that we want to actually give this class, then we put a colon. So the next thing that we are going to talk about is what we call class attributes. Now, class attributes are basically things that describe what the class is about. So you can look at it as attributes of, for example, like the name of the class is car. So by class attributes, what that basically means is that these are variables that contain some specific kind of data that describes what this class is about, that describes what the class can do. It basically helps to save data concerning that class. Now, remember that I said we can model real world entities using a class. Now, what exactly does a car have? We know that a car has a brand. So what we're going to do is we're going to say brand is equals to, let's just say, for example, a Toyota. So now we've said that our class has a brand of Toyota. Now, what else does a car have? We can say a car also has a model. So let's just say the model is Camry. Now, what else does a car have? It can have a year of production. So let's just call it year. And I'm going to equate that to, let's just say, 2025, which is going to be the latest Camry because this video is being recorded in 2025. Now we can see that we've created three variables called brand, model, and Camry. So we can see now that we have three attributes. Now these are class attributes. And basically this class or these variables, these class attributes basically describe what this car class is about. So we can see that we've stored the brand equals Toyota, we've stored the model to be Camry, and we've stored the year equals 2025. Now, what we can actually do is we can now make use of this car class. Now, we can actually reference these class attributes by just printing them out. And I'm going to show you exactly how we can do that. So I'm going to call the print method and I'm going to say print car.brand. And I can actually come down and do the same thing for model. So I can say print car.model and I will say print car.year. Now, once I run this program, I want you to see what we get in the terminal. So you see what we get in the terminal. We have Toyota being printed as Camry as well as 2025. So you see that we can actually access these class attributes which we've created called brand, model, and year. So basically, we've been able to store some attributes of this car class, which are brand, model, and year. Now, there's something that I would like to teach you about, which is what we call objects. Now, at the beginning of this chapter, I mentioned that we're going to be talking about object-oriented programming. And object-oriented programming is divided into two main things, which are classes and objects. I explained what classes are. Now I need to explain what an object is. So an object is basically an instance of a class. Now, what exactly does that mean? So let's take an example. There are currently 8 billion people on earth right now, and each of us have different names, but we are all human beings. We can look at the term human being as a class, and we can look at every single person as an object. Obviously, human beings are not objects. This is just an example. So we can look at the term human being as a class, and we can look at every single people that lives on earth as an object. Now, every single human being has the same physical attributes but kind of different, right? Every single human being has a name, they have a height, they have a gender, they have skin color, they have different color of hair, things of that nature. So every human being has different attributes that distinguishes each other, but we are all human beings, right? So we can look at the term human being as a class, and we can look at every single human being as an object. So what exactly does that tell us about objects and classes? We can actually say a class is a blueprint for creating objects. So we can also say a class is, a blueprint for representing abstract concepts and physical quantities within our code. That is the first definition I give. Now, the second definition I am giving is classes are actually blueprints for creating objects. So the class is a blueprint. We have a blueprint called human being. Now, that class called human being and produce several objects, which are different human beings that we have on Earth right now. We have 8 billion people. So we can look at those 8 billion people as different objects. We can say we have 8 billion objects. So that is exactly what an object is. It's just an instance of a class. It's a new entity that is created based on the blueprints created by a class. So you know, uh, let's proceed and explain exactly more what an object is. So right here, what I created here are called class attributes. Now remember, we are 8 billion people on the planet. Every single person on the planet does not have the same. So, for example, every single person on the planet is not black, is not white colored. Every single person on the planet does not have the same height, the same eye color. So, things of that nature. Every single person does not have the same DNA. So, we have distinguishing features that actually differentiates people from each other. And that is exactly what object oriented programming helps us do. Because I said it helps us model abstract concepts, we know that because I said it helps us model abstract concepts, that means there needs to be a way to distinguish between two different objects of a class. It's the same way when I use the bank account example. Every single person cannot have the same bank account balance. Every single person cannot have the same bank account name. So there are distinguishing factors that actually differentiate objects of a class from each other. Now, these are what we call object attributes or instance attributes. Now, what we have here are class attributes. No matter how many times I call car.year, it's always going to be 2025 because I set it as a class attribute. And if I run this now, you see that we have 2025 being printed out two times. So these are what we call class attributes. Now there's something that are called instance attributes. Now these are attributes or features that are specific to only, or these are features that are unique to only that specific object. So one object can have a car can have a brand of Toyota, another object can have a brand of let's just say Lexus, for example, or Mercedes Benz. So let's see how we are going to do that. In order to actually enable our class to create multiple objects, we need to make use of a special method called init method. Now, I am going to basically explain what we're doing now, but just type def. We're going to define a new function. Type def double underscore init double underscore open parenthesis and pass in self. Now, I'm going to explain exactly what is happening, but just follow with me. I'll put a colon and type pass right there. Now let's explain what exactly this is. Why are we having a function inside a class? Now that might be confusing, but let's proceed. Now classes can have things called methods or functions. Now these functions are basically actions that the class can, basically actions that are possible, instances of this class can perform. So let's say, for example, we have a car. What are the actions that a car can perform? A car can move, it can accelerate, it can stop, it can flash its lights, it can spray water on the windscreen, it can use the wipers to clear dirt. So these are different actions that these are different actions that our class car can perform in the real life. Cars can perform these actions. Now, how do we translate that into code? The first thing that we need to know is that, okay, we can actually store attributes for both the car class as well as the instance. Remember, I mentioned that instance or objects have variables that distinguish them. For example, different cars have different brands. So it could be Toyota, Mercedes Benz, BMW, and so on. Now, what that means is that each of these cars must have, different functions or different actions that, each of these cars have functions that they can perform because cars have functions that they can perform, which is move or accelerate. They can stop. They can, they can perform different actions. Now, those actions can be created using functions within the class. So each function is basically going to perform a specific task within the class. Now, I'm going to show you more examples of what these functions can do and how these actions can, work. But let's just proceed. Now we have a special kind of function when creating classes. This function is called the initialization function, or we can just say init, the init method. Now within a class, functions are called methods. So from now on, I'm going to be referring to them as methods. So when I hover over it, you can see we have method in parentheses right here. So what that means is that we can actually create functions and they are called method. Now, the init method is the method within a class that actually helps us create a new object of that class. And the moment you initialize a class or the moment you create a class, what I mean by create a class is I can say, for example, my car, or let me use snake case. I can say my car is equals to car. Now, this is what you call initialization. That is, you initialize a new car class or a new car object at this point. So the moment you initialize a new car object, this method will automatically run regardless of what else has been written. So the moment you type something like this, the moment you initialize a new object, this function will automatically run. So for example, I can actually test that out. I can just print this is my car, and I will just comment this for now. So once I run this, I want you to notice what we get in the terminal. So you can see that we got this printed out being this is my car. I didn't even have to call this method. The moment I just initialized this car class, it's automatically just printed out this is my car. So this means that this function, this method, this init method will automatically run anytime we create a new car or anytime we create a new car instance. Now, at this point, what we have actually done is we have initialized a new car object. So what that means is that, remember that I had explained when we call the init method, it actually helps us create a new object. So this method is responsible for creating a new object of this class car. So the moment I call this car class right here and assign it to a variable, what we have done is we have created a new instance of that class called car. So this is a new object. If I now come down here and create a new variable and call it my car2, what this means is that we have created another object of this class. So the moment I run this code, it will mean that we would have created two objects of that class. So I can actually clear my terminal screen and run this program again. And you can see that this is my car gets printed out twice because at this point we had created two instances. At this point, we had created two objects or two instances of this class called car, which is why we can see this being printed out. So if you have any questions so far, please feel free to ask me a question using the ask question button below, and I'll be happy to reply you. So let's proceed. So what we're going to do right now is we are going to create a new file inside our chapter 10, and we'll call it classes underscore and underscore objects dot py. So at this point, I just want you to save all what we've done inside this file, and we're going to proceed inside our classes and objects file. So remember that I mentioned we can create classes called, we can create any class and call it anything. And each class can have methods as well as instance attributes. Now I'm going to show you exactly what instance attributes are. Now, at this point, we created a class called car and we gave it class attributes. Now, these class attributes will always be present in every single instance of that car because these variables or attributes were defined at the class level. So the moment I move these variables inside that instance, uh, it would mean that each object will have their own different instance variables. Now, that might not make sense, but let's just proceed to write more code and I'll explain exactly what that means. So I'm going to create a new class and I'll call it car. Now, inside this class, I'm going to create the init method. So def underscore underscore or dunder, that's what it's called. Double underscore is called dunder. And I'm going to create this init method. And in here, I'll just type pass, for example. Now, there is something that I needed to explain, which I hadn't explained. So I'm just going to type self here. Now, I actually didn't explain what this self means. So I am going to proceed to explain what self means. Now, when we pass self in, what that actually means is the current object or the current instance that is currently being worked with. So when we pass self into this method, we're currently trying to reference the current object which we are working with. So a lot of the times when we're working with methods or when we're creating methods within a class, we are going to pass in self. So for example, let me create difference method and call it test method. And this will take in self. Let me just put pass for now. What that means is that anytime we make use of this test method and we pass self in, it means we are going to be working with the current object which we are going to be working with the current object which is currently being are called. So remember that I said we can create different objects within our class. What that now means is that since we can create different objects within our class, each of these objects can have different methods and we can call any of those methods on the current object. Now we need to be able to know what object we are calling that method on. That's why we pass self into it. So self is like an identifier which helps to identify what object we are currently executing. That is exactly what self is. Now, in the previous class or previous video, I explained that we have class attributes here, but there is a way that we can actually define unique attributes which every object will have. Now, the way we can do that is we can actually take in unique attributes. So I can put a comma here and take in parameters just like how a normal function would. So since our cars have different brands, models, and year, we are going to take that in. So I'm going to say brand, model, and year. So right now, what this means is that when we create a new class, we can pass in the brand, model, and year of this class. And the init method is going to create a new object, and it is going to set these attributes as the attributes of that specific. Now, right now, our init method is just taking in these attributes, but we haven't actually told it to set these attributes as the instance attributes of this car. So what I'm going to do is I'm going to say self.brand is equals to brand, and I'm going to explain exactly what is happening, but just follow with me. I'm going to say self.model is equals to model, and then I'll say self.year is equals to year. So let's look at what is happening here. So this init method takes in four parameters. So I explained that self basically references the current objects that it's working with. And then we have brand, model, and year. So these are the attributes that we want to set for these current objects because these objects will have its own special kind of attributes. Now, once we've passed that into this method and we're accepting it as parameters, what we can now do is say self does brand is equals to brand. What that simply means is that we're trying to create a new attribute for this object called brand by saying self does brand because we're saying, okay, this current object does brand. So we're creating a new instance attribute called brand. So we're saying self does brand is equals to brand, which is what has been passed into the method. So we're doing the same thing. We're trying to create a new instance method called model, and we're saying self.model is equals to model, which is exactly what we have created, which we have passed in as a parameter here. And then we're saying self.year. We're trying to create a new year attribute or a new year instance attributes for this object, and we're assigning it to the year parameter, which was passed in. So what that now actually means is that we can now be able to access these attributes from a different method. Now, this is the actual beauty of object-oriented programming. Now, if I go back to chapter 8, where we spoke about functions, if I open the mini projects.py, if we look at it, we can see that the code has been broken down into different functions. And if we actually needed to pass data between these functions, we'll see that we actually needed to if we actually needed to pass data, I mean, within these functions, we would have had to collect a parameter like data, for example. So we could pass data in there, we could pass data in here. And if we ever wanted to call view contacts, we would then have to pass data into this method. So you can see that it can get chaotic because if you have multiple functions which are going to be working with the exact same data, it would mean that you would have to pass it into the functions. Now, mind you, a function could accept multiple kinds of methods, so multiple kinds of parameters. So I could accept data one, data two, data three, and so on. And I have to make sure that I must pass all of those parameters into wherever this function is called from. Now you can see that it can eventually get chaotic because you have to make sure that all of these data are passed into the right place. But this is where object-oriented programming actually shines because what it helps us to do is it helps us to bundle data and attributes together. So it helps us to bundle data as well as behavior. Now, behavior basically means methods. It helps us to bundle data and then methods that act on those data. So let's say, for example, now I wanted to create a method to display the details of this car. Let's say I wanted to create a method that actually displays details about this car, which I have just created. Let me just delete this method and I'll create a new one and I'm going to call it def display, or let me just call it car, or let me just call it details. Now, what exactly is this method going to take in? It's going to take in self because we are trying to reference the current object that we are working with. So when I take in self, what do I want to do? I just want to print out some certain items. I'm going to print out self dot brand, and let me just do that 3 times. I'm going to print out self dot brand, self dot model, and then self dot year. So you might ask yourself, well, how exactly are we able to access self-dot-brand, self-dot-model, and self-dot-year, even when they haven't been specifically defined inside this method? Now, the beauty of object-oriented programming is that the init method takes in some certain parameters, and we can actually set these like I had explained earlier, we can actually set these attributes as the instance attributes or as the object attributes or attributes of that object by saying self the brand is equals to brand, self the model is equals to model, and self the year is equals to year. So because we have actually set these attributes for that specific object, if we now create any other method within this class and that method takes in self as a parameter, it means that we can access those parameters. Sorry, it means we can access those attributes which we defined in the init method. So it means we can actually access those attributes in any other method within the class. So let's see how we can actually utilize this. So I'm just going to go down and I'll create a new car object. So let's just say I'll create a new variable and I'll call it first car. And I'm going to equate this to car. And we need to actually pass in some certain parameters into this initialization of this new class. Notice that inside the class car in our init method, it takes in 3 items aside self. It takes in the brand, model, and year. So what we need to do is we need to pass these parameters in. So let's say our brand is Toyota, our model is Camry, and the year is going to be 2025. So this is exactly how we pass attributes in. So when we pass these attributes in, they will automatically be sent to the init method, and the init method will create a new object for this class. And as it is creating that object, it will assign some certain attributes for the instance, or it will assign some certain attributes for that specific object, like the brand, model, and year. Now we don't need to pass in self because it will automatically just take that in. It will automatically just create that by itself. So we don't have to pass any parameter for self into the init method. Now what I can then do is I can say first car dot details. So what exactly are we doing here? We created a new car called first car, and we equated this to a new object, and we passed in the values of Toyota Camry and 2025. So that will be assigned to the brand, model, and year. So what we can now do is, in order to call methods of a class to perform some certain action, all we have to do is just call the variable that we had equated this to, and we can call dot details, or the method name of dot details. So this will actually immediately just run that specific method for the object which has been assigned to test car. So let me just save that and bring up my terminal so I can run it and we'll see the output. So let me just clear my screen and run this. So when I run it, you can see what gets printed out: Toyota Camry and 2025. That is because the moment I called first car.details, it's just okay. So let me explain again. In line 13, I first of all created a new car object, or a new object, yes, using the class car, and I passed in the values of Toyota Camry and 2025. So Python came to this init method, accepted those values, and set them here. Self the brand is equals to the brand, which was Toyota. Self the model is equals to Camry, and the year is equals to 2025. Then I now went to line 14 and said first car dot details. So what it did was it just performed a certain action, which was display the details of that car to me. And it's printed them out line by line. So I can actually get rid of this to print it out in one single line by using the F string. So I can say name, or let me start by saying brand. Brand will be equals to the self dot brand. Now remember, we had talked about string formatting in, I believe it was chapter 3, or was it 4? Okay, yeah, in chapter 5, we talked about string formatting. So if you have any questions, you can just go back to that file or go back to that chapter in this course to review it. So brand is self dot brand. Then we are going to put a comma and we're going to say model is going to be self dot model, and then the year is going to be equals to self dot year. So once I save this, it's still going to print out the details, but it's now going to be on a single line. I'm just going to clear my screen and run this code. Okay, so the reason why nothing is getting printed out is because I didn't actually write print. Let me just write print. Let me wrap this in a print method, in the print method. Once I save that, I'll clear my screen again and run it. So once I run it, you see exactly what we see: brand, Toyota, model, Camry, and year of 2025. So what we can actually do is I can now come down to create a new car object. So I will just copy this, paste it, and I will rename this to second car. Let's call the brand of this car Ford, and let's change this from a Camry to Explorer. And let's change the year to, let's say, for example, 2015. So we're trying to create a new object, and the brand of this car is Ford. Um, the model is Explorer, and the year is 2015. So the moment I now call second car.details, what is now going to happen is Python is going to run this method for this second car. So let me just save that, clear my screen, and see exactly what we get in the terminal. I'm going to run this file. So you see exactly what gets printed out. We have brand. The first one is Toyota, model is Camry, year is 2025. And then we have the brand. For the second car, it is Ford, model is Explorer, and the year is 2015. So you can see now that we are capable of creating a class, and that class is capable of creating multiple objects. Now, if we didn't actually make use of a class, what that would mean is we would create this details method in a different, we would create it as its own method, as its own function. Then we'll then have to figure out how to dynamically always pass in this data. So let's actually look at the car file which I had created earlier. Now, if we look at this file, it's just basically details, and it's just an example of making use of the procedural way of doing things. So it's an example of how it would look if we're only working with functions. So here I have this function called car underscore info, and it takes in the brand and model. And you see that we are just returning the brand and model. We're returning brand and model. Then we have a different method called start car. And all it takes in is the brand model and it returns a formatted string saying the, the brand as well as the model is starting. Then we have a different method also, a different function rather, and it's returning the same formatted string. Now notice that anytime we want to make use of these functions, we are saying print, and then we're just calling that function inside the print statement because the function returns a string. And it means that that string will just get substituted in place of this function call. So notice that every time we always have to pass in the car name and the car brand as well as the name. So if, for example, we wanted to get the car info, start the car, and stop the car. Notice that we always have to pass in the same value. So we always have to pass in Toyota and Corolla every single time we want to call different functions for the same car. We'll always have to pass in the name Toyota, Corolla, anytime one calls start car, we always have to pass in the car brand as well as the name. So we have to do this multiple times. Now, if you look at this, this is a second car. Now, we also have to do the exact same thing for the Honda Civic. Want to get the car info, we pass in the brand as well as the model. We pass in the brand here, model. So we're doing the exact same thing. We always have to pass those values in. But in our object-oriented programming implementation, we know that we never actually have to always call those, we never have to pass these values into the method again because we've already passed it in once. And all we have to do is just reference it by saying self dots, by saying self dots, the instance variable name, which is brand. So I can perform the exact same example by saying start car and stop car. So I will just copy these methods, come to the class, and right under details, I will paste it here. So let me just indent this properly. So what I'm now going to do is instead of taking in brand and model, I am going to remove this and just simply type self. I'm going to remove this here also and just simply type self. Now what I can do is instead of passing in brand, I will just say self does brand, self, self does brand, and here we're also going to pass in self does model. So I'll do the exact same thing here. Self does brand and self does model. So in order to now actually make use of these methods which we have created, because these functions were pasted inside our car class, so they are now methods. All I can just simply do is, let's say I want to start the first car. All I'll just do is, let me comment details out. All I'll just say is first car dot start car. And I can also stop the car. So I'm just going to say first car dot stop car. Now you see the beauty of this. I can exactly do the same thing for the second car. So I can just change this from first car to second car. So you can see that I can just automatically call the start car and stop car for each of these objects, and I don't have to manually pass in the name, the brand as well as the model as well as the year every single time I want to perform an action. Unlike here, where we had to always pass in the brand as well as the model every single time we wanted to perform an action. And these two files actually perform the exact same action. So for example, I can just print this. I can just run this. So this won't actually do anything because I have to actually change this to print if I want to see the printout. I'm just going to put print there and I'll do the exact same thing here. I'll call the print method or function here. So once I save that, let me just clear my screen and I will run it. So once I run it, you see what it says. Toyota Camry is stopping. Ford, okay, it says Toyota Camry is starting, Toyota Camry is stopping, Ford Explorer is starting, Ford Explorer is stopping. And I can even uncomment these um I can even uncomment these details to show you that it will actually make use of these details that we passed in once multiple times within this class, because all we've passed in is self. And by passing in self, it means that we can access the instance attributes of that specific object, or the attributes or the object attributes of that specific object. So what this means now is that we've been able to create two different cars that have two different models, two different um, two different years, as well as two different brands. So let me just put a print statement here to actually print out a new line character, just so we have space in the terminal. So I'm going to clear my screen and run this again to show you how it looks like. So when I run this, you see that this is the first car. It says the brand is Toyota, model is Camry, and the year is 2025. And then if you look at this, it says Toyota is starting, Toyota Camry is starting, Toyota Camry is stopping. Then we have some space which we printed out. Then we have the second car, which is the brand is Ford, model is Explorer, the year is 2015. And we can see that it says Ford is starting, Ford is stopping. So what that now tells us is that our class is capable of modeling any single car objects that you can think of. So I want you to just, as an example, create like two more car objects, and you can pass whatever you want in there. So it can be Mercedes, it can be BMW, whatever you want. You can pass in the brand, the model, the year, and you can create these functions. You can call these methods, I mean. And what I want you to practice is actually practice creating your own special method. So think of an action that a car can perform, and you can just write it there. Write it as a method. So you can say, yes, my method, and to take in self. And inside this method, it will perform like a certain kind of action which you want your car to perform. So I want you to just do that and test it. As usual, if you have any question, kindly leave a question in the comment section or ask a question and I will reply you. And so something else that I would like for you to note is that these attributes can actually be redefined somewhere else. So they can actually be reassigned somewhere else. And attributes do not always have to be defined inside the init method. So we're going to take the first case of how attributes can be redefined or reassigned within another method. So I could actually come down here to my details method and say self does brand is equals to BMW, and I can say self dot model is equals to M4, and I can also say self dot year is equals to 2024 or so, for example. So what that now means is that I can actually reassign these variables, these instance attributes or object attributes, just like how we can do the same for normal variables. So what I will do is I will copy this line, come down here and also print. So we're going to see what it was before, and then we're going to see what it is after. So let me just comment these out so that we can only see the print out when we call details for the first object. So when I come here and enlarge my terminal, once I run this file, I want you to see what we get. You see that we have Toyota printed out first. So if I go back here, we see that we have Toyota being printed out first, Toyota Camry at 2025. But the moment we reassigned these values and printed them out again by saying self the brand, self the model, you see that they have changed to BMW, M4, and 2024. So this is the first case where instance variables can be reassigned, even though they've been defined in the init method. They can actually be changed or reassigned in a different method. Now, something else that we can do is we can actually even create new instance variables outside of the init method. So for example, I can say self.color is equals to black. And in here, after printing the year, I can say color is self.color. Now, once I save that and actually clear my screen, once I run it again, let's see what we get printed out. Okay, so we are having an error because I spelled this wrong. This is meant to be self self. So I'm going to clear my screen and run this again. So once I run it, you can now see for the first time it prints, it says Toyota Camry and 2025. For the moment I reassign the first ones and create a new instance attribute or a new instance variable, we can now see we have brand, model, year, as well as color. And it is black because that is what we assigned here, self does black. So I just wanted to explain that we don't always have to specifically I wanted to explain that it is not only in the init method that we can only create class attributes. We can create, sorry, instance attributes. We can create instance attributes in other methods, and we can also reassign or change the values of instance attributes in other methods. So it's not only restricted to the init method. So that is what I wanted to explain in this for this specific section. Now, in this section, we are going to be moving on to the next topic, and I'm going to be explaining the differences between class attributes and instance attributes. For example, in my classes and objects file, I explained what instance attributes were, and in my classes file, I explained what class attributes were. So you might be confused about what the differences are. So in this section, I am going to explain what the differences actually are. But before I do that, I just want you to also know that from each of these methods, instead of printing, we can actually just make them, we can actually just convert this to be returned. So what that means is that I can just say return this. I can just say the return keyword and it will return this string just like any other normal method. This will be returned. So this string would be returned. So what that now means is that wherever we call stop car, we can actually just come down to print out that value since the function or the method is returning a string. So I just wanted to explain to you that each of these methods can actually just return a value instead of printing it out. So you can perform some action that whatever action that you want to perform using the value that has been returned from that method. So for example, now I am printing it. I just wanted to explain that we can either, let me also print this. I just wanted to explain that we can perform both printing and returning of data from methods. So each method acts just like every other normal function, except that it can, it can return data, it can print. The only difference is that it is within a class. So the next thing that we're going to talk about, like I said, was differences between class and instance attribute. So I want you to create a new file inside chapter 10, and I'm going to say instance and class attribute .py. So I want you to create a new file, call it instance and class attribute.py. So in this file or in this section, we're going to be exploring the differences between class and instance attribute. So I'll just go to my classes and objects file and I will copy the class which we had created earlier. And I'm going to paste it here. So we just simply have a class called car and it has an init method. Now, something else that I would like to tell you is that in other programming languages, this init method is usually called the constructor because it helps to construct and create a new class. So that is why it's called init in Python because we're like initializing a new object of a new class. So it helps us to create a new object of the class, I mean. So in other programming languages, it's usually called the constructor. So now to proceed, we're trying to find out what differences exist between instance attributes and class attributes. So let's say, for example, we want to create a class called car, and all the cars that will ever be created from this car will have 4 doors. So I can create a new class attribute called number of doors, and I can equate this to 4. Now, what this basically means is that every single object that gets created using this car class will have an attribute of number of doors and it will never change because this is a class attribute. Now, the reason why you might want to define a class attribute within your class is, for example, creating variables that will never change within your class, or it is also you might also want to create a single variable that can be accessed by every single object that will be created by that class. And that variable and every single object created by that class, every single object will share the same data which has been stored inside that class attribute. Now, because we've stored created a variable, a class attribute called number of doors equals 4. What that means is that every single object that gets created inside this car class will also have an attribute of number of doors equals 4. Let's actually see how that will work. So I'm just going to go back to my classes and objects file, and I will copy this instead of writing it again. So let me just come down and paste it. So I will actually get rid of these other methods right here. So what I will just simply do is I'm going to print out first car, dot number of doors, and I will copy this and come down, and I'm going to say second car dot number of doors. So before I actually call this number of doors, let me just add this details method to our car. I'm just going to copy it, come down here and add this method so we can actually also see details of our car. And I am going to copy this line for the first car, paste it, and I will also copy this line for the second car and paste it right here. So what we've just done is we've created a method called details, and what it just basically helps us to do is display the details of the first and second cars which we had created. But I want to explain something to you. I want to show you that anytime we create a new class attribute, every single object that gets created every single object that gets created by that class all share the same value of the class attribute. So I want you to notice what happens when I run this code. So let me open my terminal right now and clear my screen. So once I clear my screen and run this file, I want you to notice what we see. So right now, let's examine what we see. So we created a new object of the car class, and we passed in Toyota Camry and 2025, and we said first car details. So it came to this method and printed out the details, which was Toyota Camry and 2025 as the brand, model, and year. Now notice what happens when we said print car first car dot number of doors. It's printed 4. Now, when we came down here to the second object, we did the same thing. It's printed the details of the car, and it's also printed 4 as the second car dot number of doors. So what exactly class attributes does is that it creates a variable, or it creates a variable or a field that can be accessed by every single object that is created by that class, and all the classes will share the same value of that specific class attribute. So basically, the class attribute remains the same across all instances unless it gets updated within the class. So for example, if I change this to 67 now and I clear my screen, once I run this program again, we see that we have 67 being printed out for each we see we have 67 being printed out for each object. So class attributes will basically remain the same across every single instance or across every single object unless it is modified from the class. So we see now that these are instance attributes. So let me just add a comment here. Instance attributes, and this is going to be called a class attribute. So for example, when you're creating a class, you might want to define a class attribute which every single object will share. So something else that I could do was I could actually just change this to 4, and I can I can actually move this. I could actually have come down to declare this here and say self dots. I can say self dot number of doors is equals to number of doors. So just follow with me. I'm coming. So I could just take this and move it into my init method as a parameter. But if I know that every single car object I'm going to be creating will have exactly 4 doors, then there is no need to put it as a parameter right here because every single car attribute that I create is going to have 4 doors. So it's going to look like I am repeating myself. So instead of always having to specifically pass that into the method, what I will just into the class call, what I will just do is create it as a class attribute like I have done here. So that would just prevent us from always repeating ourselves, from always having to pass four or whatever number of doors that your car has the into the car call. Now I want you to also notice that all of these have been passed in as parameters. So I could actually also just say brand is equals to brand here, brand. Brand is equals to brand. I can come here and say model is equals to model is equals to Camry, and I can say year is equals to that. So you could actually choose to manually specify what each value is. So I can say Toyota is a brand, Camry is a model, and 2025 is year. But if I don't pass those, if I don't specifically define what each value is, it will just automatically assign the first parameter I pass in as brand, the second parameter I pass in as Camry, and as the model, and so on. So that's basically is the difference between class attributes and instance attributes. So if you have any question, please do not hesitate to ask a question, and I will definitely reply you. So we are going to talk about the last two concepts for this beginner section in object-oriented programming. So I want you to create a new file and call it inheritance underscore and polymorphism, POLYMORPHISM dot py. So just call it inheritance underscore and underscore polymorphism dot py. So I'm going to explain exactly what inheritance means as well as polymorphism. So inheritance basically allows a class to derive properties and behavior from another class. So that helps us to promote code reuse. So what exactly does that mean? Inheritance, as the name says, basically helps one class inherit the attributes and the methods of a different class. So let's take an example. We have multiple animals, right? We have dogs, we have cats, we have, spiders. But each of those creatures are actually classified as animals. So we can have one master class called animal, and then we can have several other classes which inherits several other classes that represent each animal. For example, I can have a class called dog, and dog can inherit from a parent class called animal because dog is an animal. So let's actually see how that works. So I'm going to create a class and I'll call it animal. And this is going to just have, let's just say our animal class is going to have a simple method called make sound. And it's going to take in self. And in here, we are just going to print something. I'm just going to print some generic sound. Now let's look at this class that we have created. We have a class called animal, and it has a method called make sound. So what I can actually now do is I can come down and say animal is equals to, sorry, this is meant to be animal is equals to a new, we're going to initialize this animal class. So I'm going to say animal is equals to animal. And what are we going to do? We're going to say animal dot make sound. So let's just call that and save it. Now, once I save that and run it, you can guess what we're going to see is some generic sound because we have created a class of animal and we've called it make sound. Now, again, you might be wondering why I didn't actually create the init method by saying dot underscore underscore init and doing this. So the reason why I didn't actually create it is because by default, Python will actually create a new, it will actually run this initialization method without us having to specifically pass it in. The only reason why we might want to, create this method is if we want to perform some kind of operation the moment that class is being created. So for example, if I go back to the first file, which was called, or if I go back to the other file, which is called classes and objects, if we look at our init file, at the point of creation of that object, we wanted to assign some attributes of that object. For example, we wanted to assign the brand, the model, and the year. And we assigned them by passing those values the into the place where we called the class. So what that means is that we don't have to always create this init method. All we have to do is just, so if we're working on a class and we don't want to specifically define class attributes the moment we're creating it, we don't have to pass it in. But if you want to define class attributes like, let's just say name, then we need to create the init method the moment we need to create the init method so that the moment we are creating that class, we are going to automatically set that class attribute. So that is exactly why I didn't. We're going to automatically set the instance attribute, I mean. That is exactly why I didn't create the init method. So to proceed, we can see that we have this class called animal, and then it has a method called make sound. And when I call animal.make sound, it's just, it just automatically prints out some generic sound. Now, something else that we can do is inheritance. Now, I explained that a dog is a kind of animal, a cat is also a kind of animal. So, what that means is that we can create a new class which inherits from animal class. And by inheriting, we are basically trying to take, when we inherit from a class, we are basically taking all the attributes and all the methods of that specific class. So, let's see what happens now. I'm going to create a new class. Let me just actually do that here. I'll create a new class and I'll call it dog. Now, dog is going to inherit dog. Now, dog is going to inherit from the animal class. So we're going to say create a new class, call it dog, and pass animal into it. Now, what we're just going to simply do is say pass. So what we have done here is we have created a new class called dog, and we've told Python, okay, Python, I want you to inherit from animal. So what that basically means is that every single attribute or every single method that this class has, we are going to inherit it, and those attributes are going to be present inside the dog class. So what exactly does that mean? I can change these variables to, I can change this variable to dog, and I'm going to create a new dog class. Initiate a new dog object here, I mean. And in here, I'm going to say dog dot make sound. Now, the moment I run this code, I want you to notice what we have. You see that we also have some generic sound getting printed out. But you might be wondering, how are we able to call make sound even though that function isn't present inside the dog class? We're able to call make sound because that method called make sound is present inside the animal class, and we have inherited from the animal class inside the dog class. So what that essentially means is that we're able to access every single attribute and every single method dog inside the animal class. So I can even have a class attribute here, and I can call it species, for example. And I am not sure exactly what species dogs belong to, but I'm just going to put in, test, for example. So what that now means here is that I can come down to print dog dot species. So I'm just going to copy that. I can come down to print dog.species, and once I save it and clear my screen, and actually come back here to run it. So once I run it, you can see that we have text being printed out as well as some generic sound. So what that means is that anytime a class inherits from a parent class, we can basically have access to all the class attributes as well as all the methods that the parent class has. So the nomenclature or how we can actually name this is the class which is being inherited from is called the parent class. And then the class which is doing the inheriting is called the derived class. So here, dog is our derived class, and here, animal is our parent class. So we're basically inheriting. That's why it's called inheritance. We're basically inheriting all the class attributes as well as all the methods of that parent class. Now, there's something else that we need to talk about, which is called polymorphism. Now, polymorphism basically allows the same method to behave differently based on the object that is calling it. So let's see exactly what that means. So here in this class, animal, we have a method called make sound. But what we can actually do is we can override this method inside our dog class. So what that now means is that the moment we call dot make sound, let's just change this to bark. So let's just simulate like our dog is barking. So because it's a dog, we know that dogs bark. So let's just simulate this as our dog barking. So what this basically means is that anytime we create a new class and we inherit from, anytime we create a new derived class and we inherit from a different class, if we want to override the default method which the parent class gives, we can actually do that, and that is perfectly fine. So all we need to do is just create a new method inside the derived class, create a new method with the exact same name, and we can execute a different block of code. So this is what we call polymorphism. Polymorphism basically allows us to, it allows the same method to behave differently based on the object that is calling it. So because we have created a make sound method here, the moment I save this and I run this code, I want you to see what it gives us. You can see here it gives us back, back, back. That is because we had overridden the default method which we inherited from animal called make sound. We had overridden it inside our dog class by creating a new method with the same name, and we called it back, back, back. But if, for example, I now change this method to something else by saying, let me just say uh, dog make sound, for example. If I call make sound, instead of calling, it would first of all check. So now that I have changed this method to dog make sound and I call dog.make sound, what Python actually does first is that it comes to the derived class and checks if there is any method called make sound. If there is no method called make sound, it is then going to go to the parent class, which is animal, then it will check, does this parent class have any method called make sound? If it does, it is going to run that method. Let me just clear my screen right now and run this. So you can see it says some generic sound. But the moment I change this from dog make sound to make sound, what that now means is that if I run this again, we should see back, back, back as is being displayed here. So that essentially tells us that we are able to inherit from a class. We are then able to also override the content. We are able to override some methods of that class, and that is called polymorphism. So, polymorphism basically ensures flexibility and helps us to reduce code duplication. So let's say, for example, we want to create 5 different animals, and 3 of those animals are going to make the same sound, right? So let's just say we want to create like a cat, and a cat, let's just say we want to create 5 animals, right? And 3 of those animals are going to make the same sound. Instead of having to duplicate this method, instead of having to write this method 3 times in those 3 different classes, what we can do is we can create a parent class called animal and write this method once. And we can have those other 3 classes inherit from our animal class so that we don't always have to write this make sound method. Since all of them are going to be making the same sound, which is some generic sound, then there is absolutely no need for us to copy this method and paste it 3 times in those 3 different classes. All we can do is create a parent class, define it once, and those other 3 classes can inherit from our animal class, and then they will be able to call the same method. So this is basically one of the great um, ways object-oriented programming helps us. It helps us, it prevents code duplication, and it prevents us having to always repeat ourselves. And it's also flexible because you can choose to inherit from a class based on some certain variables that you want to get. You can choose to inherit from it, make use of some certain variables, and like we have done here, and you can choose to override some certain methods, like we have done right here in our dog class. So we could actually even create a new class called cat, and cat can inherit from animal. And in here, we can just say pass. So I can come down here and say cat is equals to cat. And here I can say cat dot make sound. So when I say cat dot make sound, it's just basically going to call this make sound method, which is present in my animal class. So once I clear my screen, I run this. You see, it says some generic sound for the cat. But if I now create a method called make sound inside this cat class, and I change this to meow, and I save it. Once I clear my screen and run it, you see that we have back, meow, 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 because we said cat dot make sound. So that's exactly what inheritance and polymorphism means. Now it can become a whole lot complex. Now what that means is that you can actually inherit from a class which has inherited from a different class. Now we know that dogs are animals, but we also know that dogs have different breeds, right? So I can also even come down here. So this is where it can get complex. So I can come down here and create a new class and call it German Shepherd, because a German Shepherd is also a different kind of dog. It's a dog breed. And this can inherit from dog. And I can just say pass. Now, what exactly does this mean? So we have a class called German Shepherd, and it's inherited from dog. Now, the dog class actually inherited from the animal class. So what that tells us is that we can have multiple layers of inheritance being created in our file. But although it's typically usually not advised, because then your code becomes very complex and difficult to manage. But this is something that is actually possible. We could even have another class inherits from German Shepherd. Now it's also one of the beauties and one of the things that make object-oriented programming complex and kind of difficult to manage. It is when you have multiple levels of inheritance. So that is why it is generally not advised to do that. But what we can do is we can actually create a new method here inside our animal class, and we can say it, for example. Now, because every single animal has to eat something, then we can create a method called eat. And we can print out something saying some eating some generic food. Now, once I save that, I can actually I can actually then create a new initialization of my German Shepherd class. So I can come down and say German Shepherd dog is equals to German Shepherd. Let me just copy it here. I'm going to come here, copy it, come down, and I'm going to say call German Shepherd. And I'm just going to come down and say German Shepherd dog dot eat. Now you might be wondering, how am I able to call dot eat? Now I am able to call dot eat because if you remember, German Shepherd inherits from dog and dog inherits from animal. So what that means is that dog is going to inherit every single attribute of the animal class. So it's going to inherit test, this species is going to inherit make sound, it's going to inherit eat. So what that means is that in the dog class, it has access to all the methods and attributes that the animal class provides. Now, because German Shepherd is inheriting from dog, it also means that by extension, it is inheriting not only the attributes and methods of the dog class, but it is also inheriting all the attributes and methods of the animal class. So because I created a method called it inside my animal class, that now means that I can definitely access it inside my German Shepherd class. So What I can actually do now is run this file. And you can see it says eating some generic food. So we're able to access this method called eat, which is present in the animal class from the German Shepherd class. And as usual, you can actually override this method. So I can say it, I can call it inside the German Shepherd class. Now I want you to notice what happens when I run it. So when I run it, it says eating some generic food. So let me just change this to German Shepherd eating meat, for example, because dogs like meat. So once I save that and run this code now, let's see what we have. You see, it says German Shepherd eating meat. So that basically means that we can have multiple levels of inheritance, and each level basically inherits all the attributes and all the methods of the parent class. So dog is a derived class of animal, and German Shepherd is a derived class of dog. So you can have multiple levels of inheritance, and you can have what you call polymorphism also. So at each level of inheritance, you can decide to make use of polymorphism to override a specific method, or to override a specific method which has been present inside the parent class. So right here we had make sound, and I used polymorphism to override the make sound which was present inside animal. I can also do the exact same thing right here for make sound. So for example, if I call German Shepherd dot make sound, we know that we're going to get back, back, back. So for example, I can come down and I can say, let me just copy this. I can come down and say German Shepherd dot make sound. So I'm just going to do that and save it and clear my screen. So once I save that and run this file, see what we get. We get back German Shepherd eating meat and then back, back, back. We get back, back, back because the German Shepherd class inherits from the dog class, which has a method of make sound. So we can, by extension, call this make sound method because the dog class, which is it is inheriting from, has a method called make sound. So I know that this can be complex in a way, but if you have any question, please feel free to ask a question in the comment section, or you can create a new, question or comment, and I will definitely reply you. Please feel free to ask. I know this might be confusing in some kind of way, but I will definitely explain if you leave a question in the comment section. So before we move on to the next chapter, I realized that there was something that I actually left out. Now, in the last section of this course, I had explained, how inheritance worked and how we could inherit from the parent class and how the new class is called the derived class. Now, there's something that I hadn't mentioned. In the parent class here, it had a class attribute of species and it had a method right here of make sound. But what I didn't explain is how to inherit from a class that has a constructor or that has an init method defined. Now, what Python actually does is when you inherit from a class, if that class has an init method, what Python expects you to do is it expects you to channel the parameters which are required for the parent class in its method. It expects you to channel those parameters from the derived class or from the child class back to the parent class, which is person. So in this example, I have the parent class called person, and it has an init method, and it just takes in the name of the person as well as the age, and it sets those values. It sets the instance attributes of the name and age. Now, we have a different class called employee, and employee is inheriting from the person class. Now, earlier, when we ran the code, it didn't give us any issue. Now, in this case, when I come down to say my employee and I initialize a new employee, if I run this code, I want you to notice what it gives us in the terminal. You can see it gives us an error saying missing two required positional arguments, name and age. So what that means is that when Python ran this program, it's tried to initialize this, it's tried to create a new object of the person class because we are inheriting from the person class in the employee class. Now, when it's tried to run this initialization code, it realized that name and age were not passed into passed, so it failed and said two required conditional arguments, name and age. Because if employee is inheriting from a person, then that person definitely has to have a name and age. And at this point, that person object has not been created, or that person instance has not been created. So what we need to do is we need to let our employee class, we need to create an init method in our employee class that will collect the name, age, as well as an employee ID. And then it will channel that name and age back to this person class, which is the parent class. So let's actually see how to do that. So we're going to come here and create an init method inside the employee class. So it's going to take in self. It's also going to take in name, age, as well as employee underscore ID. Now we're going to see exactly what is going to happen. So I'm just going to put a colon here and press enter. So this our employee method, or sorry, employee class is going to take in the name of the person, the age of the person, as well as the employee ID. Now what we need to do is we need to channel this name and ID, or we need to pass this name and ID into the constructor method of our parent class, which is called person. So the way we can do this in Python is just simply saying super. Now this is an inbuilt method that we can make use of in object-oriented programming. So what we can simply just do here is say super dot underscore underscore init. And I'm going to explain exactly what this is. Now pass in name and age. What exactly does this mean? When we say super, we're basically just referencing the class which we inherited from within the employee class. So super is just basically trying to reference the parent class, which is person, right? So what that means is that we can just substitute it, for example, by saying person.init. That's what Python is doing in the background. So we're just calling super.init. When we say .init, we're trying to call the init method inside this person class. And then we're passing in the name and the age because those are the required fields. So what I can now do next is with employee ID, I can create an instance attribute using this employee ID. So I can say self.employee ID is equals to employee ID. Now, when I now come down to initialize this new employee object, what I'm just going to pass in is name is equals to John Doe. Then the age is going to be, let's just say, age is going to be 67 or 68. And the employee ID, I'm going to set employee ID equals 1 because this is the first employee that we're creating. Now, the moment I clear my screen and run this again, we shouldn't see any error being printed to the terminal. So you can see that there is no single error right now being printed to the terminal. That is because we have successfully been able to take these details, which are name and age, as well as employee ID. We've passed it to our constructor inside. We passed it to the init method in the employee class. Now, what the employee class is now going to do is it is then going to pass that name and age into our person class, which is right here, by calling super. When we say super, we're trying to reference the parent class, which we inherited from. And then we're going to say super.init because we're trying to reference the init method inside parent class. And then we're going to pass in name and age. Then we're going to set the instance variable of the employee class called employee ID to what has been entered in the init method. So that is why we no longer get an error. So this is exactly what I wanted to explain, how to inherit from a class which actually has an init method and it is expecting some certain parameters to be passed into the method. This is exactly how we are going to do it. Now, in this section in chapter 10, we are actually going to be working on a mini project. So what this project is going to do is, in order to solidify all that we have talked about, in order to solidify the knowledge of object-oriented programming, we're going to be working on a very simple project that combines topics like object-oriented programming with topics like arrays together so that we can fully understand how these techniques work together. So we're going to be working on this simple project. It says create a program that allows adding, viewing, and deleting employee details using OOP principles. Now, if you remember where we talked about inheritance, I explained exactly create how we can inherit from a class that has an init method. So we're just going to come here and copy exactly what we have here, and I'm going to explain why we are doing this. So in order to actually start working on this project, we need to look at the structure. So it says create a program that allows adding, viewing, and deleting employee details using OOP principles. Now, we know that an employee is definitely a person, right? So using these OOP principles, we're going to talk about um, inheritance also, so that that knowledge can be solidified. So we have a person, and that person has a name and an age. Now, because employee is inheriting from person, it means that an employee is also a person. So the employee, by extension or by means of inheritance, is also going to have a name and an age. Then right here, the employee is also going to have the employee ID. So when we create a new object, it would mean that a single instance of the employee class is going to have both name, age, as well as the employee ID. So all we have to do then is to create a way that we can is to write the code that will enable us to create multiple employees, store them somewhere, retrieve all these employees, and delete them. Now, before we actually start working on that method or that functionality, what we're going to do is we're just going to create a method inside our employee class that will help us display information about this specific employee. That is, we want a method inside our employee class that will help us display the employee's name, age, and employee ID. We're just going to call it details, def details, or detail. Okay, we can leave it as details. So I'm going to say dev details, and this will take in self. Now, all we're just going to do is we're just going to print out a very, very simple formatted string. I'm going to print f, and in here, I'm going to put the formatted string. So the formatted string is going to be name, and we're going to say self.name. Again, we can say self.name because we have inherited person, and person contains this instance attributes of name and age. So because we have inherited person, it means we have access to these variables or this class attribute, instance attribute, I mean. So self.name, I'm going to say age is going to be colon self.age, and then employee ID. Employee ID is going to be self.employee underscore ID. So all this is just going to help us do is print out the details of this is supposed to be name. All this is going to do is help us print out the details of a specific employee. Now, what we're going to do is we're going to create a different class which will help us manage all of the operations. The operations that we wish to perform are adding a new employee to our list, deleting an employee, as well as viewing all the employees within our list. So let's just use a list as our database. So we're also going to be making use of a list. So we're going to create a class that will actually handle all of these actions. So let's create this class, and we're going to call it employee manager. As you can see, we're using the Pascal case. Now, this class isn't going to inherit from any other class as employee inherited from person. What we're just simply going to do next is we're going to create an init method. And I'm going to explain exactly why we're doing this, but just follow with me. We're going to create an init method. And in here, let's just put pass for now. Now, since our employee manager is meant to be able to store all employees in a list, that is, when we add an employee, we want all the employees to be stored in a single place. What we're going to do is we're going to create a class attribute, and we're going to call it employees, and we're going to equate this to an empty list for now. So this is going to be a class attribute, meaning that it's going to be available to every single instance that gets created, every single instance of employee manager that gets created. And every single instance is going to have the exact same copy of employees because it is a class attribute. And a class attribute can't be changed they can't be changed the from each instance. Every single instance is going to have its own copy of the employees class attribute. Now we have this list right here, and it is going to help us store something. It's going to help us store a list of employee objects. Now remember that when we were talking about lists, I told you that lists are very dynamic. They can hold data types of different forms. Now, what we're actually doing here is when you create a class, you're actually creating your own kind of data type. I had explained that when we create a string, for example, so if I go to data types where we talked about it, when you do something like this, what we're doing is we're actually equating a value of 70.6, which has a data type of float, to grade. So what that essentially tells us is that float has a class. It is an object of a class. And we can actually come down to print the type of grade just to see what we get in our terminal. I'm just going to come up here and run this code. So once we run it, you can see it is a class of float. What that means is that, like I explained before, every single value that we specify has a data type, and that data type is actually a class. That is why we say class of float. So what that tells us is that we can actually create our own data type. So for example, I can come down here and I can say my employee, or let me just create a person class actually. I can say person1 is equals to person. And in here, I'm just going to pass in the name and age. So let's just say John, and I'm going to pass in 67. So I can then come down and say print type of person one. And I want you to note what we get when I run this code. So once I run this, what do you see? We see a class and we see underscore underscore main of dot person. Now, what this is essentially telling us is that this variable person one is representing the value here is representing a class, right? And that class is of data type person. So what that tells us is that person itself is our own, it's a class, but it's also a data type. It is a user defined data type, which we have just created. So classes actually in Python are a way of creating our own kind of special, data types, which we have seen when we printed out the type of this. It gave us a class of float. So when we in turn printed out the type of person, it gave us a class of person because the name of our data type is person. Your data type name is basically the class name. So that is what I wanted to teach you about. So let me just clear this out for now. So after creating a list of employees, we said that this list is going to store, it's just going to store all the employees which we are going to be adding. So when we add a new employee, that employee instance or employee object is going to be stored inside this employee list. We know lists are dynamic, so they can store data types of different kinds. So inside this init method, all we're just simply going to do is we're going to put pass for now. And the next thing is that we are going to create a different method. Now, this new method that we're going to create is just going to display to the user the possible operations that they can perform. And it's going to request the user to enter the operation that they wish to, that it's going to tell the user to enter the operation that they wish to execute. So I'm just going to create a new method and I'll call it operation. And this is going to take in self. We'll put a colon here and press enter. So I'm just going to print out a string. Now, this string is just going to basically display all the options that our program is capable of, all the actions that our program is capable of performing. I'm going to put one. So one is going to be for adding a new employee. So I'm going to say add employee. And I'll put a line break and I'll say two is going to be view all employees, right? So view all employees. And then we'll put another line break. And then three is going to be delete an employee. And after printing this values out, let me just put a backslash n. We are then going to make use of the inbuilt method or function to actually collect a value from the user requesting what option they wish to perform. So I'm going to say uh, user operation, that is what the user wants to select, is going to be equals to the input method. And in here, we're just going to say enter or select operation. Now we're going to, okay, ERATION. We're going to wrap all of this inside the int keyword because after collecting it, what we're going to do is we're going to convert it into an integer so that we can check whether the user entered one or two or three in integer format. That is why we're wrapping it in int. So after collecting this operation, we are then going to perform, we're then going to create other methods. We're going to create a method for adding an employee, another method for viewing an employee or viewing all employees, and a third method for deleting an employee. So this operation method is basically going to help us always print out the operations that the user can perform, as well as request the operation that the user wants to perform. It's going to always do that. So we're going to leave this operation method for now. Let's just come back to our init method. So what we're just going to do is we're going to call this method and say self.operation. So self.operation. Now, what exactly does this mean? Now, what this basically means is that the moment this class is initialized, that is employee manager, the moment we run this program and the moment we create a new employee manager instance, it's going to immediately call this self-operation. It's going to immediately call this method. Now, what this method is going to do as we see it, it's just going to print out these values and ask you to enter some data. So let's actually test that. So I'm going to say manager is equals to employee manager, and I'm just going to call it. Now, once I save this code, go back up and press play. Let's see what we get. You see that we have these options being printed out: add an employee, delete an employee, and view all employees and delete an employee. You can see it's now asking us to select an operation. The moment I press one, for example, the program ends because we haven't actually done anything with the inputs that we are collecting. So that tells us that our program immediately it gets in uh, our program basically helps us call this self the operation the moment a new object or a new instance of employee manager gets initiated. Now let's write the code or the first method which is required, which is add employee. Now what we simply need to do is create a different method which is going to help us add an employee. Let me remove this empty space here. I'll come down here and say def add employee. I need to take in self. Now, what exactly do we want to do inside this method? Now, inside this method, we want to create a new employee. Now, remember that in order to create a new employee, we need the name, age, as well as the employee ID. Now, we are going to actually have to collect these details from the user. That is, we'll collect these details from the terminal, that is the console, when we run the program. And then we are going to use those details to create a new employee, and then we're going to add that employee to this list. We're going to append that employee to the list. So let's see how we're going to do that. So the first thing that we're actually going to collect from the user is name, followed by age, followed by employee ID. So let's do that. I'm just going to say name is equals to input, and I'm going to say enter name, or let me just say enter employee name. So let me just copy this so I don't always have to write it. So enter employee name, and then the age is just going to be int of inputs, and inside inputs we're going to say enter employee age, and the last thing is the employee ID. So actually we don't really need to wrap this in an int because we're not trying to do anything special using the age character, or using the age, I mean. So the last thing is employee ID, and this is going to be equals to, Now we're going to convert this into an integer actually because it's an ID, so IDs are typically integers. So I'm going to put an input, I'm going to call the input method here, or input function, I mean. And in here, I'm just going to say enter employee ID. And I'll put a colon there. So at this point, this method is going to help us request name, age, and employee ID. Now, after collecting all of these details, what do we want to do? We want to create a new employee. And after creating that new employee, we're going to add that employee to this our list of employees right here. So let's just create a new variable, and I'll say new employee is going to be equals to. Then we're going to create or initialize a new object of our employee class inside this method. So we're going to say employee. And what things do we need to pass into this employee class? Remember, we need to pass in the name, the age, and employee ID. And then the name and age will automatically get passed the to the parent class, which is person. So that name and age will automatically get set here. So what do we need to do? We just need to pass name, age, and employee ID. So all we need to do is just pass these values in, or you could specifically also say name is equals to name. You could say age is equals to age, and employee ID equals employee ID. But I'm just going to go with the short route and just pass a name, age, and employee ID. So after doing this, we're just going to append this new employee to our employees list. I'm going to come down and say employees dot append, because okay, let me just make sure I am okay. So this is employees. So what we're just simply going to say is self dot employees dot append, and in here I'm just going to pass in new employee. So the reason why we can say self.employees is because employees is a class attribute. So it is a class attribute that just stores the list of employees. This is why we can say self.employees. That is, we're trying to access the employees list within this object. And remember, the object is always going to have access to these employees. Every object is always going to have access to these employees um, list because it is a class object. And then we can call dot append because it is actually a list. I remember when we spoke about list methods, which was right here, we spoke about dot append, which basically helps us add a new item to a list. So we're basically going to be adding that new employee to the list. So let me just write a comment to describe all of this. So I am just going to say create a new employee instance slash object. And here, what we're just doing is save the employee to lists. We're basically just saving that created employee to this list. So that is what this first method is going to do. Now, what we need to do next is the second operation that our project should be able to perform is viewing all the employees within this list. Now, if you remember, we had created a method here called details, and it basically just displays the details about a specific employee. So what we're going to do is we're going to write a method which will loop through all the employees within this list and call this method. Now, I am going to explain exactly what that means, but let's just proceed. Let's create a new method and call it def view employees. And this is going to take in self. And what we're going to do is we're going to write a for loop that loops through all these employees. Now remember that this employees list stores a list of employee objects or employee instances. And because each of these employee instances already has this method, which is called details, attached to it, what we can do is we can look through every single employee in this list and call this method for it. So it will display the details for each employee. So I'm going to write a for loop here. I'm going to say for employee in self dot employees. That is, I'm saying self dot employees because I'm trying to reference this object. I'm going to put a colon there. Now, all we're just going to simply do is we're just going to say employee dot details. So we can actually rename this to view employee. So I think this is a better description. This is a better name. I'm just going to copy it. I'm going to say for employee in self.employees, I will just say employee dot view employee, and I'm going to call it. So what we are simply doing here is, since this our method, since this our list is going to store a list, since it's going to store a list of employees, and each of these employees are objects, and each of these values are objects of the employee class. It simply means that we can call this method for each of those objects that are stored here. That is why we are saying for employee in self.employees, employee.view employee. So it's going to call this method and display the detail. So what we can actually do then is put a backslash n, so that it will always create a new line after printing out one of them. Now, the next or the last option is we need to actually then write code, which is going to help us delete an item or delete an employee from our list. Now, what we are going to do is we are going to also write another method for this. So I'm going to say def view delete employee, and this is going to take in self. Now, what exactly do we want to do inside this method? What we want to do is, in order to delete an employee, we're going to delete that employee using the employee ID. So this method, when it is run, it is going to ask the person, okay, enter the ID of the user which you wish to delete. Now, after it has entered the ID of the user that it wishes to delete, we're now going to search through this employee list. We're going to search through this list and check for the employee object whose employee ID matches what was entered. We're going to see exactly how that works, but let's just, proceed. So we're going to create an input. We're going to create an input field right here. So I'm just going to copy this since I already have it up. Now, once I have copied it, it's just going to say enter employee ID to be deleted. Now, once we have been able to grab that employee ID and store it in this variable, what we're going to do is we're going to write a for loop that will go through every employee in this list, and it is going to check, is the current employee's ID equal to this employee ID that was imputed? If it is, then we're just going to remove this item from the list using the dot pop method. If we go back to list methods.py, you see that we can pop items from this list. But we're actually going to be we're actually going to be removing that item from this list using different method. So back to our method, we're then going to write that for loop that will loop through all the employees. So let me just copy this for loop right here. So I'm going to say let me close this out, sorry. So I'm going to say for employee in self.employees. So we're trying to reference this employees list. So we're saying for employee in self.employees, what do we then want to do from here? What we're just simply going to do is check if that current employee, that is, if this current employee has an ID, that is, has an instance ID that matches the employee ID that was entered by the user, then we're going to remove it from this list. So we're going to then write a for loop here. I'm going to say if employee dot ID is equals employee ID, which is what has been entered here, then we're just going to simply say self dot employees dot remove. And what are we going to remove? Okay, sorry, employees dot remove. And what are we going to remove? We're simply going to remove the current employee, which is this current employee. So let me explain exactly what is happening here. Now we've said for employee in self.employees, that is loop through this entire list of employees, which by the way is storing objects. Now, because it is storing objects, we can just say, okay, actually, instead of ID, it's meant to be employee ID. So this is not meant to be ID, this is meant to be employee underscore ID.
So we are basically looping through this thing. We're saying for employee in employee self.employees, if employee.employee ID equals this one that was entered here, that is, if this current object, which is inside this array, if the employee ID of that object matches what was entered, we're just going to say self.employees.remove. Now, lists have another method called dot remove, and it basically helps to remove an item from a list. So we have two ways of removing an item from a list. We have dot pop, we also have dot remove. So they both do the same thing. The only difference is that dot pop takes in the, let me just go through it again. The only difference is that dot pop takes the ID, that is the location of the item that you wish to remove, while dot remove takes in the value itself. So if I wanted to make use of dot remove, I would just say names dot remove, and in this case I'll say Jane. So this is meant to be names dot remove Jane. So dot pop just takes in the ID of the sorry, it takes in the index, it takes in the index of the index position of the value that you wish to remove, while dot remove takes in the actual value itself, not the index. So that is basically the difference between dot pop and dot remove. So what I'm just simply saying is, okay, we're telling Python to remove this employee object from our list. Now that is all we need to write for the delete employee method. So what we're just simply going to do is, since we already have all of these methods created within our class, we're just going to start calling them from the operation method. So what I'm going to say is, I'm going to say if user operation is equals to 1, and if it is equals to 1, we just want to add an employee. I'm going to call self.add employee. So what this basically tells us is that we can call other methods within a specific method in a class. So if I'm in a method called operation, what that simply means is that I can call another method within the same class and it will properly run. This is exactly what we did here in the initialization, in the init method. I just simply called self.operation from this method. So we can call other methods from a single method. Then I'm going to say else if the user operation is equals to 2, then what does that mean? The user wants to view all employees. So I'm going to say self dot view employees. Then I'm going to put um else if user underscore operation is equals to 3, then what I want to do is delete an employee, right? Is delete employee. Okay. Self actually dot delete employee, and I'm going to call that method. So once I do that, our program basically is able to perform different operations based on whatever the user has selected, right? So if it is 1, the user adds an employee. If it is 2, the user views an employee. If it is 3, the user deletes an employee. Now, at the end of all of this, it is then able to perform all of these different operations based on what the user has entered. Now, there's something else that we need to add. So after each operation has been performed, let's just display the list of operations again so that the user can see all the operations that can be performed. I'm just going to come down here and call self the operation. So it's then going to print out everything, print out all the operations, and ask the user for the operation they want to perform. So it always asks the user for the operation they want to perform after it has finished performing any of the operations entered. I'm going to call self the operation. And right here, I'm also going to call self the operation. Make sure you don't call self the operation inside any of these indented blocks. Make sure it's at the end of the processing. So all I'm just going to do is I'm just going to save it. Now, once I save that, all we have to do is just basically run this program. So if you have any question, please do not hesitate to ask me a question and I will definitely be happy to reply you. So let's just open the terminal and see what we have. So I'm just going to open it wide and I'm going to run this program. So once I run the program, you can see it first of all asks us what operation we want to perform. Let's enter one to add an employee. So you see, the moment we enter one, it is asking us to enter an employee name. And that happened because right here, the moment we entered one, it's called self.employee. So it's called this method on itself. So let's just enter the employee name as John, employee age as 56, and the ID as 1 because this is the first employee. So when I press enter, you can now see that it immediately asks us to enter to select the operation again. That is because after performing all of these operations, we just simply told it to say to call self the operation. So it came back to this method and ran all of this again. But let us actually put a line break so that everything looks better. So I'm going to break out of the terminal by typing Control C. That is why all of this broke out. And I'm going to run this program again. So I'm going to add an employee. Let's just say John. Let's just say age is 56. ID is 1. Now I'm going to add a second employee, and the name is going to be, let's just say Solomon. The age is going to be 78, and the ID is going to be 2. Then let us add a third employee. So this person is going to be named David. Age is going to be 23, and the ID is going to be 3. Now let's just view all employees by pressing 2. So when I press 2, let's look at what we were given. So the moment I press 2, you can see that we have 3 different items being printed to the terminal. We have the name is John, age 56, employee ID 1, name Solomon, age 78, employee ID 2, as well as for the last person which we had entered. So you see that the moment we entered 2, Python immediately called this view employees method, and it's looped through all the employees inside the employee list, and it's called this method, which is employee.view employee. And that method is right here when we said view employee. So it just basically calls that method and displays all of these details to the screen. Now let's say, for example, we wanted to delete like the second employee, which has an ID of 2. I'm just going to enter 3 to delete an employee. Now we're going to enter 2 because we want to delete the second employee. When I press enter, we are now seeing that it asks us to select the option we wish to perform. Let's just say 2 because we want to view all employees. Now, the moment I press enter and go up, you can now see that we can only see 2 employees being printed because if we come to this delete employee method, what Python did was it looked through our list, it checks to see if the employee ID that was entered here matches the employee ID of any of the objects which has been saved to this employees list. Now, the moment it saw that okay, we have the second item has the ID which was entered to be 2, is then deleted all the employees. And I can do the exact same thing. I can delete the first item, and the moment I press 2, you see that we have only 1 employee printed out to the screen. So that is exactly how our program works. So you see that our program is capable of performing multiple operations. So I can just end this and clear the screen. So you see that our program is capable of performing multiple operations, and everything is working beautifully. So I've been able to make use of classes, inheritance. We've made use of lists. We've made use of for loops, conditionals, as well as calling objects, calling methods from within the class. We've made use of the input method. So you can see how all of these concepts which we have talked about from the beginning are actually coming together to build a more complex project. I believe we built something similar when we were talking about functions. Was that in chapter 8, mini project, where we built this mini project where it said create a program where users can add, view, and delete contacts using dictionary. So we were able to do all of this using functions. Now, what I'm going to tell you to do is just to test your knowledge. I am going to ask you to try and recreate this entire program, but using classes only. classes and methods, as well as obviously objects. Try to convert all of this code, which has been written in a procedural manner, where everything has been divided into methods. Try to convert this code into an object-oriented paradigm type code. So we write everything using classes and objects. And if you have any issues, kindly leave a comment and or leave me a message, and I am going to definitely reply you. So that is all we're going to talk about in this that's all we're going to talk about in this section. Now, I want you to also note that this can be written in different ways. Even though I have, broken it down into different classes, and I have decided to call this operation method inside the constructor, you could also write it in totally different ways. For example, I could decide to change this init method to a method called run, and all I could do here is I can come down to say manager.run, and it would still do the exact same thing. It would just call this run method, which would call this operation method. So it's the exact same thing. So you could just tinker with it and write it in any way or form that you think might work, as well as also try and attempt converting all of this into an object oriented code.